Hello, I'm Michael Morrow and welcome to the video presentation of Engineered Standard Time Systems. Have you implemented an ERP system and wondered how to cost-effectively measure and implement routing times? Are you worried about the standard costs of your manufactured product? Do you have routing times in your ERP system but don't know how they were calculated? Do you want to measure your production efficiency? Have you effectively measured the success of your lean implementation? This video presentation will introduce the concept of engineered standard time systems, which can address these questions. To implement an engineered standard time system, we need to understand what is a standard time. Standard times are used for productivity measurement, product costing, and capacity calculations. A standard time consists of the basic, or sometimes known as normal time, and allowances. The basic time is effectively the cycle time of a process, the time taken to complete a process in one cycle. The basic time can be calculated from historical data obtained over a significant period of time, from times recorded from production timesheets, for example. The times are dependent on the accuracy of the records and typically do not record process details. Time study. Through the use of stopwatches or video analysis, times can be calculated from direct observation. Care must be taken to adjust the times from time study to take into account the pace of the operator, that is, fast or slow pace. This is known as rating and requires skill of the observer to accurately rate the times. The times that have been rate adjusted are known as normal times. Time studies are common due to the relative ease of direct observation. However, time studies do not necessarily go into the detail of the optimal process and are required to be performed for all process variations, example for different product variations, and can only be calculated when the process is in operation. Predetermined Motion Time Systems. This method calculates the basic time by analyzing the manual motions utilized in a process. The most well-established and widely used predetermined motion time system is Methods Time Measurement, or MTM. Any manual operation is analyzed into the basic motions required to perform it, and assigns to each motion a predetermined time standard, which is determined by the influencing factors, for example, the distance reached and the degree of control under which it is made. Predetermined motion time systems, by their nature, involve reviewing the motions required to conduct a process and identify value-added and non-value-added tasks as a result, providing an opportunity to streamline the process. In the original MTM system, MTM1, the basic motions are reach, grasp, move, position, and release. For simplicity, a second-generation MTM system was developed, MTM2, where the basic motions have been combined into motion sequences get and put. In this presentation, we will be focusing on the application of MTM2 in the engineered standard time system. Fatigue can affect the performance of operators of a process, where their pace can be slower at the end of a shift compared to when they first started the shift. Other factors such as consistently lifting heavy objects, poor lighting, heat, dusty environments, and mental fatigue can detrimentally affect the performance of operators. To account for a loss of performance due to fatigue allowances are incorporated into the standard time calculations. Here are examples of fatigue allowances sourced from the International Labour Organization. The engineered standard time system introduced in this video presentation offers one huge advantage. It is modular. For many processes in an organization, it can be seen that if processes are observed and broken down into smaller work elements, many elements of the processes are often repeated and shared among different processes. A significant amount of time and money can be saved by focusing on calculating these data blocks through the use of MTM2 and building basic times from these data blocks rather than calculating every basic time for every process using time studies or other observational means. For each data block, MTM2 is used to analyze the motions used in the process element and calculate a time for the data block. The MTM2 motion analysis involves documenting the layout of the process, identifying the position of the operator and how many steps were taken to perform the operation. Documenting the equipment used, including consumable items, jigs, and fixtures. The weight of the items used are also documented. Determining the motion sequence and MTM2 code for each element used for both left and right hand, taking into account the distance the hand is moved and the degree of control required. Assigning the predetermined time values for each motion sequence code. Adding all of the time values for a total process time. The process times, calculated from the MTM2 motion analyses, are summarized in an MTM2 data block summary table. The data block summary table may simply be a spreadsheet, as shown in this presentation, or a more sophisticated database. The table includes all data block variations. Thanks to using a modular approach, the MTM-based times resulting from variations can be predicted and calculated without having to resort to conducting time studies or educated guesses. The variations in data blocks may include variations in product dimensions, weight or features that affect the time to handle or process the product, or layout dimensions. Variations in layout can affect the number of walking steps required by the operator. Each data block is assigned a unique code to enable identification. Each data block also has a description of the motion analysis in plain English, derived from the MTM2 motion analyses. Standard times are calculated from identifying the data blocks that are required for the total process and assigning appropriate fatigue allowances and machine allowances if machines are used in a process. Spreadsheets can be used to calculate the standard times or by using a database. Thanks to the modular approach used in this system, we can calculate variations in the process time. In this example, there are different times for packing widgets of different lengths, from 2,100 mm to 3,000 mm in length. In this video presentation, we have introduced the concept of engineered standard time systems utilizing MTM2. By adopting this approach, engineered standard time systems can have a huge positive impact on cost-effectively measuring and implementing routing times, can accurately capture labor times for standard costs, can provide a method of traceability for routing times in your ERP system, can provide a basis to measure production efficiency, can be used to effectively measure the success of your lean implementation. Now that's something to think about.